I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this lecture series, we are going to see the topic on dielectrics and its polarization method for the unit dielectrics and steady electric current. So we know conductors are having large number of free electrons, but the dielectrics or the materials do not have any free charges. Because the charges in dielectrics are bound by finite forces, hence they are called as bound charges. Since the charges are bound, they cannot contribute to conduction process, but if subjected to electric field intensity E, they shift their relative positions. So this shifting of their relative position of bound charges allows dielectrics to store energy. So now we come to the polarization part. So because of the applied electric field intensity, the shift in positive and negative charges are in opposite directions. So under the influence of an applied electric field, such charges acts like small electric dipoles because they have both positive and negative charges separated some distance. So we can say that it is an electric dipole. So these electric dipoles produce an electric field which opposes the externally applied electric field. So this process, due to which the separation of bound charges result to produce electric dipoles under the influence of electric field E, is called the polarization. So in the diagram we can see the unpolarized atom of a dielectric before the application of electric field. So here we are considering electric field is 0. What happens is the number of positive and negative charges are equal and the atom of dielectric is said to be electrically neutral. So here the both positive and negative charges are considered as point charges of equal amount coinciding at the center. So there is no existence of dipoles, and this is called as unpolarized atom. Now we are coming into polarized atom of a dielectric. So now the electric field is applied. So because of the applied electric field, the symmetrical distribution of charges get disturbed. So positive charges experienced a force F is equal to QE, and a negative charge experienced a force F is equal to minus QE in the opposite direction. Thus there is a separation between nucleus and the center of electron cloud. So this atom is called as polarized atom. So now to obtain the mathematical expression of a polarization, it is defined as P is equal to Q into D. So this D is the distance between the negative charge and positive charge of the dipole, and if there are n dipoles in a volume del V of a dielectric, then the total dipole moment is obtained by adding all the individual dipole moments, that is Q1 D1 plus Q2 D2 up to Qn Dn. So this is given as summarization of k is equal to 1 to n Qk dk. So the measure of intensity of the polarization is defined as polarization P as the dipole moment per unit volume of the dielectrics is given by P is equal to limit del V tends to 0 summation k is equal to 1 to n Qk dk by total volume del V. So and the D displacement density vector is given as D is equal to epsilon naught E plus the polarization P, and the polarization P is given as Xe, epsilon naught and E. So this Xe is called electric susceptibility of the material, and it is more or less as a measure of how sensitive a given dielectric to electric fields. And we know the relation D is equal to epsilon E. D is the displacement density vector or electric flux density, and E is the electric field, and both are related with a constant called permittivity of the given dielectric material. This epsilon is given as epsilon naught into epsilon r. So epsilon naught is permittivity of free space. It is 8.854 into 10 power minus 12. farads per meter, and epsilon r is called relative permittivity, and it is related with susceptibility of the material 1 plus Xe, or it is given as epsilon by epsilon naught. So as the problem is given, so here the magnitude of D and P for a given dielectric material in which E is equal to 0.15 millivolts per meter and Xe is given and it is 4.25. We know the formula for a dielectric medium. The displacement density vector D is equal to epsilon E. So epsilon naught, epsilon r is obtained by 1 plus Xe. Here Xe is given, it is 4.25. So by adding with 1 we get 5.25, and D magnitude value is obtained by multiplying epsilon naught epsilon r value, and also the electric field intensity. So and the force is obtained by epsilon naught into Exe. So the polarization. So the polarization answer is 5.644 into 10 power minus 15 coulombs per meter square. So in the next problem also epsilon r is given, D is given, they are asked to find out the polarization value. So by using the formula P is equal to Xe epsilon naught E, we can get the values. Thank you.